So here's a little refresher about how we solve right triangles using trigonometry. Okay, so we have to have a right triangle. Any other type of triangle does not use our normal sine, cosine, tangent, secant, cosecant, cotangent relationship. It uses other things. And we have to at least know two sides, right? We have to know two things about our right triangle. We either know two sides or we know one side and one angle. Okay, we have to know two things about our triangle in order to solve for anything. Right? If we only know one side, then it's just a dumb triangle and we can't do anything. And if we only know one angle, then it's just a dumb triangle and we can't do anything. So we have to know two things. We either know two sides or we know a side and an angle. So let's assume for a second that we know two sides. Okay, let's see. Let's call this side 8, and we'll call this side 10. Okay, we know two sides. Any two sides. It doesn't matter what two sides we know. Okay, the first thing we can do is calculate your missing side. And we can do that by using the Pythagorean theorem. Okay, we're going to use the Pythagorean theorem from geometry, which says the sum of the legs of a right triangle is equal to the square of the hypotenuse, right? The sum of the squares. So that means we need to have a variable. Okay, we'll call you x. So we can find our missing side of the triangle. So Pythagoras looks like 8 squared plus x squared equals 10 squared, right? Your hypotenuse side, which is across from your 90, by the way, always across from the 90, goes by itself. So we do some cute little algebra, right? We square 64, we square 10, we minus the 64 over here, and we get our missing side is equal to 6. Check. Okay? So if we're going to solve our triangles, that means we need to find all the other missing things. So the first thing we find is a missing side, and then we have to find our missing angles. Okay? First we find your missing side, and then we find our missing angles. So we'll call this lower right angle A, and we'll call this upper right angle B. Right? Those are nondescript variables. They just were the ones that were in my head at the time. How are we going to figure out what angle A's measure is? Trigonometry. So for angle A, 8 is the opposite side, 10 is the hypotenuse. Which trig relates the opposite to the hypotenuse? That would be the sine. Sine is a ratio of the opposite side to the hypotenuse. So the sine of angle A, that's what we're trying to solve for, is our missing angle A, equals the opposite side, which is 8, over the hypotenuse, which is 10. So we write the equation sine of A equals 8 over 10. Now since A is our variable we're trying to solve for, I need to get rid of sine. So how do I move sine to the other side of my equation? We do the inverse. So inverse sine of 8 over 10. And this is what we plug into our calculator. And since we're in degree mode, our calculator is going to give us an answer that happens to be in degrees. So angle A is 53.1 degrees. For my class, we don't have to do any more than 1 decimal place for an angle. That's plenty accurate for our angles. Okay, now that we know angle A, how do we find angle B? Geometry is how? The 3 angles of a triangle add up to 180. And if one of them is already 90, that means the 2 angles have to add up to 90. So angle B plus 53.1, that's angle A, must equal 90. Okay, so if we know 2 angles, we can always find the 3rd angle by just doing geometry. In this case, that's... So we found all of our missing things. We found our missing side. We found our missing angles, right? We've calculated all of those things. Pythagorean theorem to find the side, trigonometry to find the first angle, and geometry to find the second angle. Okay, now let's back up for a second. What if we only know one side and one angle? So let's do that scenario. So the first thing we can do is we can figure out what our missing other angle is, right? We have this one sitting up here. We can do that using geometry. So, well, we'll still call this angle B. So angle B will be 90 minus 32, right? Because the two non-right angles of a triangle add up to 180. 90 minus 32 is 58 degrees. Okay, so we'll keep that as 58 degrees. That's the first thing we can do, pretty easy, is just use our geometry and subtract the known one from 90 to figure out what that angle is. So now we can figure out what our two sides are. We'll call this side A, and we'll call our hypotenuse C, just for Pythagorean theorem's sake. So it doesn't matter which one you find first, so choose. Do you want to find A or do you want to find C? So I'm going to find C first, just for fun. For angle C, C is the hypotenuse, 7 is the adjacent side. So which trigonometry am I going to use to find angle C? Or rather, side C. That's going to be the cosine. The cosine relates the adjacent side of the hypotenuse. So cosine of 32 equals adjacent 7 over hypotenuse C. So C is my variable. How do I solve this equation for C? Well, the first step is to get C out of the denominator. So I multiply both sides by C, right? C goes, no longer is C in the denominator. So C times the cosine of 32, right? This is a number, equals 7. So what's my second step in solving for C? Dividing both sides by cosine 32. Okay, and we will find that anytime our variable is in the denominator of our ratio, we're going to end up dividing in our calculator. If it's in your denominator, we divide. So there's the length of my hypotenuse. Okay, so anytime your variable is in your denominator, we're going to end up dividing in your calculator. So now we know two sides of our triangle, and how do we find the third? We could always use the Pythagorean theorem. But just to make a point, I'm going to use trigonometry. Okay, if I want to figure out what side A is the opposite side and 7 is the adjacent side. That means I'm going to set up a tangent equation. Tan of 32 equals, nope, not 7 over A, but rather A over 7. Okay, the adjacent side over the opposite side over the adjacent side. So how do I solve this one? I need to, once again, multiply by my denominator, okay, to get it away from. So here, I'm basically done. I just have to type this into my calculator, 7 times the tangent of 32, and that will give me the value for A. .3741. So, in general, right, to reiterate, if your variable is in your denominator, we're going to divide in our calculator. And if our variable is on top, then we're going to times in your calculator. Okay, so the operation that you perform depends on the position of your variable. And then, of course, if you want to find an angle, we always take the inverse trig of whatever fraction that happens to be. Okay, hopefully this has helped, and that's all the things you need to know about solving right triangles using trigonometry and geometry and the Pythagorean theorem. Okay, goodbye.